Hello, Algebra 1 students. This is Mrs. Raposa. In this lesson, you will be learning to solve quadratic equations using the quadratic formula. And this is the quadratic formula right here. And we can only use it if a quadratic equation or a degree 2 equation is set equal to 0. Remember what Mrs. Vanas told you, that the zeros of the equation are what values of x make y equal 0. Sometimes the zeros referred to as the solutions. What are the solutions to the equation? And you're going to see that they are usually the x-intercepts when y equals 0. These are the steps that I'm going to refer to as we do examples 1, 2, 3, and 4. Okay, so let's do example 1. Example 1 is negative 3x squared plus 10x minus 3 equals 0. The first step on your notes is already done. Set one side equal to 0. That's done for us. The second step is to write down the values of a, b, and c. Remember that a is the coefficient of x squared, that's negative 3. B is the coefficient of x, that's positive 10. And c is the constant term, that's negative 3. Step 3 says to find the value of b squared minus 4ac. What number do we have to take the square root of? That number is called our discriminant. So let's do that for step 3. So b squared minus 4ac is going to be 10 squared minus 4 times negative 3 times c, which is negative 3. Our a and c values just happen to be the same here. That doesn't always happen. This is where a lot of students make mistakes, and it has everything to do with these negative signs. 10 squared, that's easy. That's just 100. But I am actually going to be subtracting something from 100 here instead of adding. Let me tell you why. Because I have 3 negative signs. And every pair, 2 of them, cancel each other out. So now I'm just going to have 1 minus sign left. So I'm going to be subtracting something from 100. And that number that I'm going to be subtracting from 100 is actually 4 times 3 times positive 3. 4 times 3 is 12, times 3 is 36. So 100 minus 36 is actually 64. So my discriminant is actually 64. So that's the number that I'm going to be taking the square root of, 64. So let's go ahead and do step 4. And I'm going to erase all this to finish the problem out. So I'm going to replace the negative b with negative 10. Negative b just means the opposite of b, so it's going to be the opposite of 10. And 2 times a is actually 2 times negative 3. And 2 times negative 3 is going to change to negative 6. So that's what I end up with here, negative 6 in my denominator. So let's go ahead and calculate this out. Now what I'm going to have is negative 10 plus or minus the square root of 64, but the square root of 64 is a whole number, that's 8, all divided by negative 6. That means I'm going to have 2 answers, so I'm going to put 2 arrows to go in 2 different directions for those 2 answers. One of my answers is going to be negative 10 plus 8 over negative 6. And the other answer is going to be negative 10 minus 8 over negative 6. Always do what's in the numerator first. That'll give me negative 10 plus 8, which is negative 2. And I divide that by negative 6. And that's going to give me positive 1/3, because a negative divided by a negative is positive. That's one of my solutions. To get the other solutions, let's do this. Do the numerator first. That's going to be negative 18. And then divide that by negative 6, and I get my second solution, which is positive 3. So my 2 solutions to this equation are 1/3 and 3. Those are my zeros, because those are the numbers that if I plug them in for x, I'll get y is 0. Okay, I'm just going to throw the equation into Desmos to check my answers to example 1. Example 1 was negative 3x squared plus 10x minus 3 equals 0. I replaced the y with 0. Let's graph it. And the solutions were 1/3 and 3. So that means that when x is 1/3, or 0.3 repeating, y will equal 0. And when x is 3, y will equal 0. So you can see why the solutions, or the zeros, are sometimes referred to as the x-intercepts. So those solutions were correct. Okay, to do example 2, I first need to do the first step, set one side equal to 0. It's not done for me already. I'm going to set this side equal to 0 since there's only 2 terms here. To do that, I need to get rid of the positive 9. So I'll subtract it from this like term, its constant term over here. Both sides of the equation do the same thing. And I also need to add 4x to each side of the equation. Whatever I do to the right, do to the left, I'm going to add 4x here because that's its like term, not here. And when I'm all done, this side ends up being 0. Because these cancel and these cancel. And on this side of the equation, I end up with 2x squared plus 7x minus 3 when you add these together. So my values of a, b, and c are 2, 7, and negative 3. Be careful. If we had used, without setting the equation equal to 0, we may have thought that a was 2, 3, and 6. Remember, a, b, and c are determined when it's set equal to 0. So these are my values of a, b, and c. Let's do step 3 now. Let's find out what the discriminant is. B squared minus 4ac. So b squared minus 4ac, that's going to be 7 squared minus 4 times 2 times c, which is negative 3. So b squared ends up being 49. And I can see that I'm going to add something to 49 because this negative and this negative, a pair, cancel each other out. So I'm going to add something to 49. And the number is 4 times 2 times 3, which is 8 times 3 or 24. So my discriminant is 73. So that's the number that goes under the radical sign. So now let's go ahead and do our calculations. I'll have x equals negative b, which is negative 7. Plus or minus the square root of 73, all divided by 2 times a, which is 2 times 2. So that ends up being negative 7 plus, I'm going to use a decimal approximation. The square root of 73 is about 8.54. Yes, 8.54. I already went to the calculator and did that. And I'm going to divide that by 2 times 2, or 4. This is where I go in 2 different directions to get my 2 answers. One answer is going to be negative 7 plus 8.54 over 4. And the other solution is going to be negative 7 minus 8.54 over 4. Simplifying the numerator first, I get 1.54 divided by 4. And that, when you put it into the calculator, you get approximately 0.385. So there is one of my solutions. The other solution is going to be negative 15.54. Do the numerator first, divide that by 4, and you're going to end up getting about approximately negative 3.885, I believe. So those are my 2 solutions. Are my 2 zeros to this equation, right? My zeros to this equation are the solutions to the equation 2. Okay, so to check my answer to example 2, the solutions to this equation, remember after we set it equal to 0, we had a new equation right here, y equals 2x squared plus 7x minus 3. And we set that equal to 0. And so the solutions to example 2 are the zeros of this equation. And those zeros, as I can see, are the x-intercepts. And they occur at negative 3.886. That's close to what we had. We had an approximation. And about 0.386. So yes, those are indeed the solutions to that equation. Okay, so let's do example 3. X squared plus 25 equals 10x. And step 1 is to set one side equal to 0. So I'm going to set this side equal to 0. Whatever I do to the right, do to the left. I'm going to subtract 10x. But there aren't any x terms over here. I'm just going to have to put it right here. So when I'm done, I get 0 on the right side, but on the left side I have x squared minus 10x plus 25 equals 0. I have to use Kleenex for my erasers. There we go. So now let's find the values of a, b, and c. A is just 1 because that's 1x squared. B is negative 10. And c is positive 25. So the next step is to find, step 3, find the discriminant, b squared minus 4ac. And that's going to be negative 10 squared. Be careful, negative 10, when you square it, that means to multiply it by itself, you're still going to get positive 100. B squared is always positive. Just keep that in mind. Minus 4 times a times c, which is 25. So I'm going to have 100. Let's see, do I subtract something or add? Now be careful because this goes away when I square the number. So this isn't one of the ones that gets canceled out. I don't worry about that. That just becomes 100. But I only have one negative sign here. There's nothing to cancel it out, so I'm going to subtract something from 100. And it's 4 times 1 times 25, which is 100. So my discriminant ends up being 0. So 0 is what I take the square root of. So let's go ahead and finish solving this problem. And what I'll have is I'll have x equals negative b, which is negative negative 10. So it'll be a positive 10 plus or minus, because remember it's the opposite of b, opposite of negative 10, plus or minus the square root of 0, all divided by 2 times a, but 2 times a is 2 times 1. The square root of 0 is just 0. So this just really ends up being negative 10, positive 10. Positive 10 plus or minus nothing divided by 2. And it doesn't matter whether I do negative 10 plus 0. I keep saying negative 10, it's positive 10. If I do 10 plus 0 over 2 or 10 minus 0 over 2, I still get the answer 5. So I really don't need to go in two directions when the discriminant is 0. There's only one solution to this equation, and that solution is 5. This equation is true when x is 5, because 5 squared is 25. 25 plus 25 does equal 10 times 5, which is 50. So it does work. Okay, let's take a look at example 4. It wasn't set equal to 0, so I first had to subtract 6 from each side to get one side equal to 0. And I end up with negative x squared minus 6x minus 10 equals 0. My values of a are going to be negative 1, b is negative 6, and c is negative 10, my constant term. Step 3, find the discriminant, b squared minus 4ac. Well, b squared is negative 6 squared, and that's 36. From 36, remember the negative sign gets taken care of when I square the number. I'm going to take away 4 times negative 1 times negative 10. Every pair of negatives, if there's a pair, they cancel each other out. But I am still left with 1 because I have an odd number of negatives. And I'm going to take away 4 times 1 times 10, which is 40. And 36 minus 40 is negative 4. So when I use the quadratic formula, I end up with negative b, which is negative negative 6, plus or minus the square root of negative 4, all divided by 2 times negative 1. But I can stop right here, because if I go to the calculator and try to take the square root of negative 4, I'm going to get an error message. That's because the square root of negative 4 does not exist in the set of real numbers. So I can't even really do this. I can't even go any further. This actually has no solution, which means there is no value of x that I can plug into this equation, and that will be true. Okay, if I want to check graphically my solution to example 3, when I set that equal to 0, I had x squared minus 10x plus 25 equals 0. And you can see that there's only one 0 or one x-intercept, and that's when x is 5, then y is 0. Let's take a look at example 4. Example 4 was when I set that equal to 0, I ended up with negative x squared minus 6x minus 10 equals 0. And we said that there was no solution. And you see how there's no x-intercepts? There are no values of x that will give me a y value of 0. So in summary, the discriminant of this quadratic formula tells us how many solutions there are to the equation. If the discriminant is a negative number, I cannot take the square root of a negative number, and that means that there's no x-intercepts, there's no real solutions. If the discriminant is equal to 0 itself, there's going to be only one solution and one x-intercept when y equals 0. And if the discriminant is a positive number, what I'm taking the square root of here is positive, then there will be two x-intercepts and two real solutions.